Hello, Jennings Geniuses. Welcome to Math on the Porch and the next to the last production from Jennings Studios. Woohoo! All right, today we're going to do 4 review problems and then I'm going to read you a story. So you need pencil and paper. Make sure you have an eraser, and I'd like you to work along with me and do the math and not watch the math. All right, the first thing we're going to review is addition with larger numbers. So I want you to write this number, 4,740 plus 1,672. And remember, once we know a concept in math or a skill, we can keep building on that and using it to do bigger and bigger things. So if you know how to add with and without regrouping, then you can add numbers that are huge. You're just going to have to keep doing the same procedure again and again if you're using the algorithm. So go ahead and stop the video and solve. All right, you asked yourself a question. Will I need to regroup? Understand, plan, solve, check. I understand I need to add. I understand I'm adding 4-digit numbers, and I know that sometimes I'm not going to have to regroup. Sometimes I am. So I'm prepared to do both. 0 ones and 2 ones is 2. 4 tens and 7 tens is 11 tens, so I have to take that over here. And then 100 plus 700 is 800, plus 600 is 1400. And then 1000 plus 4000 is 5000, plus 1000 more is 6,000. So the sum, which is the answer to addition, is 6,412. And I hope you got that. I'm sure you did. All right, let's move on to the next one. We're only going to do 4 problems and then I'm going to read the story. The next problem is going to be subtraction. Again, let's subtract into the thousands. So everybody write 3006 minus 127. Now that you've written that, let's understand, plan, then solve and check. So understand that I'm subtracting, I'm taking away. Make a plan. Well, I see I'm going to have to regroup, but not only that, I see that when I go to get what I need, I'm going to have to subtract across 0. So go ahead and solve that. Even if you're a little shaky, just solve it, because then you will be able to compare what I did with what you did, and you'll be able to clarify your thinking. So everybody pause the video and solve. All right. Well, remember we talked about Theodore, Helen, Tarun, and Olivia. All right, so the bill payer comes, the bill collector, and he needs $127. From Olivia, he needs $7. Olivia does not have $7, so she can't pay. She goes and asks Tarun, Tarun, I know you always have 10s. Can I borrow $10 to pay this guy? And he says, no, I'm sorry, I don't have anything. I'll go next door and ask Helen. So he goes next door and says, Helen, I know you always have $100 bills. Could you please loan me 100 so I can help out Olivia? And she says, I'm sorry, I don't have anything. I'm going to have to go to Theodore. So she goes to Theodore and asks to borrow $100. Theodore only has cashier's checks in the amount of $1,000. He can't give her a $1,000 bill because there used to be one, but there's not one anymore. And I don't know why. Probably because it was easy to hide stolen money. All right, so anyway, I digress. So he says, yes, you can borrow some. So now he only has 2,000 and he gave her a cashier's check for 1,000. So she gets it right here. 10 hundreds is 1,000. Agreed? So Tarun says, Helen, can I borrow $100 now? She goes, yeah, I'm loaded. I've got all these $100 bills. So she lends him one of her $100 bills. So now she only has 9. So Theodore only has 2,000 now. Helen only has 900. But Tarun now has what he needs to help out Olivia. So now he says, Olivia, I have it. I have 10 tens. I have this $100. I can lend you 10. So 100 minus 10 is going to be 90. And now at last, Olivia gets what she needs. She's got 10, but what mistake did I make? It's a common one. Tarun lent her $10, but we have to remember she already had $6. So now she's got 10 plus 6. She's got 16. All right, 16 minus 7 is 9. 90 minus 20 is 70. 900 minus 100 is 800. 2,000 minus nothing is 2,000. So the difference, which is the answer in a subtraction equation, was 2,879. Now let's go ahead and check. Understand, plan, solve, check. We're going to ask ourselves if this is reasonable. If we had $3,006 and we spent $127, is it reasonable that we would have $2,879? One way some people like to do this is just do it, round the numbers, and see if that makes sense. 3,000 minus 100 would be 2,900. And was our answer close to 2,900? Yes, 2,879 is very similar to 2,900, and that tells me my answer is reasonable. All right, let's move on. Got 2 more problems to go, then I'll read you a story. All right, I want you to draw what I draw. We're going to make a row of 4 dots. We're going to make another row of 4 dots, and then we're going to have 1. All right, let's suppose that these represent Oreos. And you have 2 friends over. Wow, won't that be a wonderful day when you can have 2 friends over? And you have these 2 friends over. And you are going to split the Oreos with your 2 friends. You're going to share them equally. So it's one set for you, 1 set for one friend, 1 set for the other. Circle and show me what each person is going to get. Well, there are a lot of different ways you could do it, but I started with, okay, 3 for me, 3 for friend number 1, 3 for friend number 2. So the answer was basically 9 divided by 3 into 3 parts equals 3 for each person. Or another way to say is 1/3 of the set of 9 was 3. There's a third, there's a third, there's a third. Fractions can represent regions or areas like pizza, but fractions can also represent parts of a set. So this 1/3 of this set equals 3 Oreos. All right, let's erase last problem and then the story. Okay. Here's our final problem. And it has to do with the last 2 lessons that I hope you watched and worked along with. I'm going to be checking that this afternoon. Let's draw a rectangle, which is a polygon, poly, mini, gon, sides. And we're going to put some measurements on here. This side of this rectangle is 6 inches long, and this side is 3 inches long of this 2D, two-dimensional figure. Now we're going to write down here P equals, and that means perimeter. And we're going to write A equals, and that stands for area. Now let's suppose that Preston is building a dog pen in his backyard. No, inches is not going to work. Let's suppose that Preston is building a cricket pen, because inches will work for that. And he wants it to be 6 inches long and 3 inches wide. But how much cricket fencing does he need to buy? He needs to buy this 6 inches. He needs to buy this 3 inches. 2 numbers are missing. How is he going to know how to do it? Fill in the missing numbers. Well, what do we know about rectangles? We know opposite sides are parallel, and we know opposite sides are the same length. So 6 inches, 6 inches, 3 inches, 3 inches. Add up all the cricket fence he needs and write it here for perimeter and put a unit. pause the video. All right. I had 6 and 6 is 12, and I thought of this as 6. 12 and 6 is 18, but it is not correct unless you have a unit. What's the unit? He's buying his little cricket fence in inches. Now, yesterday you had a whole video about area. Perimeter means like building a fence. Area means like buying carpet to cover a whole floor. Or I gave the example of buying concrete pavers to make a patio. Or you could think of our classroom floor. How many tiles did they need to cover the area of our classroom? And the way you find that, we learned last time, was you multiply the length. Everybody write this. This is the way you write the little formula. Length times width equals area. Length times width equals area. So what's the length? Write it with me. 6 times, what's the width? 3. What is 6 times 3? Go ahead and write the answer. 6 plus 6 plus 6, we just did that when we were doing perimeter, is 18. So we're going to write our 18, but we have to write a unit. And we cannot write inches. Inches refers to length. We need to write square inches. So we can even draw those squares. Look at this. Bam. 6. There you go. That's all the eensy weensy weensy carpet squares that Preston's going to put in this cricket pen. And let's count them. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Always, 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 area will be in square inches because you're trying to cover an area. All right, let's erase. At last, the story. This is from a series that we've read before. We read All the King's Tens, and we read Off the Charts Dessert. And today I'm going to read Circumference and the Great Knight of Angleland. More than anything, Radius wanted to be a knight. Every day he practiced riding, sword fighting, and archery. His teacher was the brave old Sir Degrees. One day, Radius's parents, Circumference and Lady Di of Amateur, came to watch his lessons. "Show us what you have learned," they said. In the riding ring, Radius mounted his horse, and Sir Degrees gave directions. "Knightly right angle, trot!" shouted Sir Degrees. So Radius rode his horse to the center of the ring and made an exact right angle turn, and it formed a perfect square corner. "Now double the right angle to make it a straight angle." So a right angle is 90 degrees. He wants a 180-degree angle. Called out Sir Degrees. Radius rode at full gallop straight across the ring. He came to an abrupt stop right in front of his parents. "Wonderful!" they exclaimed. "You have learned so much." So, straight angle, 180 degrees. At supper, Sir Degrees said, "Radius is the best squire I have ever taught. He's ready to go on a quest." "He is not old enough," said Circumference, looking worried. Lady Di smiled. "You were the same age, dear, when you went on your first quest." Radius sat up straighter. "I am ready, Father," he said. "Please let me go." Circumference slowly looked at each of them, and finally he smiled and nodded. "Hurrah!" shouted Radius. "I will make you proud. But how shall I find someone in need of help?" "Our neighbor, King Lel, has disappeared," Sir Degrees answered. "Many have set out to find him, but none has ever returned." "I will search until I succeed," promised Radius. The next morning, Radius made ready to go. "Remember your nightly right angle," Radius counseled Sir Degrees. "It will serve you well." Circumference and Lady Di gave Radius an old family heirloom, a medallion in the shape of a perfect circle. "What are these numbers around the edge of the medallion?" Radius asked. No one knows, Lady Di answered, but it may bring you courage on your journey. Radius bid them farewell and set off. I'm on a quest, he exclaimed gleefully. Radius rode for many days through the countryside. One day he came upon a tiny village where all the cottages had rooftops pointed in steep angles. What a quaint little town, thought Radius. Mother would call it cute. He asked a villager about King Lel. His castle lies beyond the mountains of Obtuse, said the villager, pointing to the east. But take heed, there are tales of strange creatures and dangerous labyrinths. No one traveling there has ever returned. I hope to be the first, said Radius. Farewell, and thank you. Up and down through the mountains of Obtuse, Radius rode eastward. Finally, Radius came upon a walled castle, surrounded by a watery moat. He rode cautiously onto the drawbridge. It creaked and groaned with every step. As he neared the middle, the drawbridge began to crumble. Quickly, Radius urged his horse across. Just as they reached the other side, the old drawbridge collapsed into the water with a tremendous splash. That was close, Radius exclaimed. He rode through the high gates of the castle. In the courtyard, Radius saw a parchment hanging on a door. He took the parchment and read the faded writing. Warning, stranger, friend, or foe, dangers wait as forth you go. You must make a nightly rite, finding necks big, straight, and slight. One wrong turn means loss to all, in a writhing, screaming fall. Find the right to reach the king, or you will feel the dragon's sting. And it was signed the brothers Zig and Zag. What can this mean, thought Radius. Clutching his medallion for courage, he rode through the doorway into a circular chamber. In the middle of the stone floor, Radius could see a carved circle with a line across its center. All around him, arches led into different rooms. Which way should I go? He wondered aloud. He read from the parchment. You must make a nightly rite. Sir Degrees and I practiced many right-angle turns. Just then, something flapped out of the shadows and bumped his arm. Oof! Grunted Radius as his medallion went flying. The medallion rolled away and came to a stop on the carved stone circle. Radius noticed that the number 90 pointed directly toward one of the arches. Starting at 0 on my medallion, if I go to the center, to the number 90, that forms a right angle. That's the nightly rite, he cried. So Radius swung himself back onto his horse and rode through the arch that was a nightly rite, or a 90 on the medallion. The way was dark and damp. Around him unseen things scuttled in the corners. By the light of a flickering candle, Radius read the parchment again. Finding next, big, straight, and slight. What is big, he wondered. Could it be something even larger than the nightly right angle? He thought for a minute. The mountains of Obtuse were shaped like big angles, he remembered. As Radius looked around for a way out, spider webs caught in his hair, tickling his legs, and brushed against his face. Ahead, Radius saw several hallways. Each had a circle carved in front of it. If I hold the medallion over a circle, then the number measures the angle into the hallway, he said. The angle of the first hallway measured only 55 on the medallion. As Radius measured the angle of each hallway, he found only one that was bigger than a right angle. One angle measured 120 degrees on the medallion. Radius entered that hallway, but it ended at a curving stairway. Radius dismounted and told his horse to wait. "Stairs are no place for you," he said. "Stay right here. I'll come back as soon as I can." The stairway was narrow and steep. "I must be under the castle by now," Radius thought, and he noticed that the further down he went, the hotter it was. The stairs came to an end at a fiery pit where huge flames leapt up like angry snapping jaws. Two bridges spanned the inferno. They both started from the same spot, but they crossed the fire pit at different angles. "After big, the parchment reads straight," Radius remembered. "That's 180 on my medallion. You can't get an angle straighter than that." He took a deep breath and ran across the bridge that went straight over the roaring fire. On the other side, Radius heaved a sigh of relief. Whew! He opened a heavy door and entered a dark tunnel. The door clanged shut behind him. Raspy snuffling came from deep in the darkness. 4 glowing eyes appeared and began moving slowly toward him. Clutching his medallion, Radius hurtled down the tunnel. As he passed the eyes, he brushed against scales that felt like cold chainmail. Radius ran blindly on, stumbling as the floor started to slope upward. Behind him, heavy thumps echoed in the darkness. The tunnel ended. Other tunnels shot off at different angles. In front of each was a carved circle glowing with its own light. "The parchment says a slight angle," Radius mumbled, "like the rooftops in that cute little village I passed through. A cute little angle is what I need. Something less than 90 on my medallion." The smallest angle measured 40, so he turned there. The thumps grew louder. Something snuffled and sniffed as if hunting for him. Radius ran through the darkness. "Next will be the right to reach the king. Another knightly right, angle of 90. At least the last angle will be easy," he gasped. He was wrong. In the dim light, he came across 4 corridors, which all seemed to be right angles. Fingers fumbling, he measured quickly with the medallion. 90, 90, 90, and 90 again. "Slow down," Radius told himself, "and measure once more." He carefully lined up the medallion and read the numbers. The first angle was 93. "Too big," he said. The next angle was 85. "Too small," he muttered. The third one was 89. "Almost right," he said, and then there was a great whooshing sound and thick smoke filled the tunnel. Radius was caught inside the dark cloud. Coughing and sputtering, he felt his way along to the remaining corridor. "I hope this is the one," he whispered. Something was lurching toward him. He stumbled. Suddenly, Radius ran into a wall of stone. He was trapped. The thumping grew louder. Whatever it was big, and it was right behind him. Radius turned and stood with his back to the wall. His arm bumped into a latch, a handle. He pushed with all his strength, and a door swung open. Brilliant sunshine met his eyes. "Welcome," a voice bellowed. "Who might you be?" Radius squinted into the brightness. "I am Radius, son of Circumference and Lady Di of Amateur, and squire to Sir Degrees. I'm searching for King Lel." "It seems you have found him," chuckled the king. "But how did you do it?" Radius bowed. "My medallion helped me figure out which paths to take. Knowledge gave me the courage to keep going," he explained. "But there were frightful things in there." A whimpering came from behind the door. King Lel opened it wider. Radius jumped back. "Dragons!" he gulped. "A pair of them!" "They are my loyal pets, the Lel dragons," exclaimed the king as he scratched their heads. The poor beasts and I were trapped in the maze by my evil cousins, Zig and Zag. But we are free now that you have found the way through the labyrinth. Young squire, he continued, anyone brave enough and smart enough to figure out that maze deserves his knighthood. With Radius's medallion, they easily found their way back through the maze. To celebrate King Lel's freedom, invitations were sent to all the neighboring knights and ladies, Circumference, Lady Diameter, and even old Sir Degrees came. Radius and King Lel went to the moat to greet each group of guests. When King Lel whistled and called out, "Pair of Lels!" the two dragons stretched across the moat, side by side. They became a living drawbridge for the guests to cross. Everyone asked Radius how he found his way through the maze. "I discovered the secret of the medallion," Radius said. "The numbers divide a circle into 360 parts. I can use those parts to measure any angle. I call the parts of a circle degrees in honor of my teacher, Sir Degrees." Radius drew a picture of his medallion and took an arrow from his quiver. Let's say this arrow points to the hallway. The number shows how many degrees are in the angle. A right angle measures 90 degrees. A straight angle measures 180 degrees. I call angles bigger than 90 degrees obtuse, after the mountains of obtuse. Angles smaller than 90 I call acute. They look like the roofs in a small village I traveled through. King Lel told Radius to kneel. "For your bravery and intelligence, I knight you Sir Radius," the king proclaimed. "From this day forth, let this kingdom be called Angleland. Banners will fly on every castle tower. They shall show knightly right angles of 90 degrees, small acute angles, large obtuse angles, and straight angles of 180 degrees. Rise now, great knight of Angleland." The crowd cheered, and Radius rose to greet them. Angleland was the only kingdom to have a castle with a living drawbridge. The cry, "Pair of Lels!" brought the two dragons over the moat. They became so famous that today parallel means any straight line side by side, the same distance apart, like the Lel dragons. Angleland is still there on very old maps, but today we call it England. I'll see you next time.